Okay, we're now going to construct a confidence interval around this proportion difference. Now, here's the idea. Remember that the key thing we're looking at here is the distance between the two proportions. We're not comparing it to a claim, we're saying how far away are the two proportions from each other. And so as a result, our confidence interval is going to be a measurement between how far away the two groups are from each other. As a result, the formula for a confidence interval is we take that difference, because remember the difference is what we want to measure. This is what we want to build our confidence interval around. So it's going to be that minus some margin of error and plus some margin of error. So we want to measure the true difference between the two groups, and so it's going to be minus some margin of error and plus some margin of error. We'll trap the true population difference. Now, the margin of error here is a little bit tricky. It's equal to z alpha over 2, which is our critical value, times a giant square root, and the square root is p1 hat q1 hat over n1 plus p2 hat q2 hat over n2. Okay, so notice we don't do p bar here, we don't do q bar here. This is all p hat and q hat. So let's go ahead and see if we can plug this into the formula. It's going to be a little long, but here we go. P1 hat and P2 hat, remember, were the two values we calculated at the very beginning. So that's going to be 0.109398 minus 0.135897436 minus the square root of, now we actually haven't calculated Q1 hat or Q2 hat, so let's do that really quickly. P1 hat was equal to 0.109398 from earlier, and from earlier P2 hat was 0.135897436. And so let's find Q1 hat and Q2 hat. We just do 1 minus 0.10, 1 minus 0.109398. And I get 0.890602. And now let's find Q2 hat, which will be just 1 minus P2 hat, 0.135897436. So that's 0.864102564. So we've got our values. So it's going to be 0.109398 times 0.890602. That's P1 hat times Q1 hat, divided by our first sample size, which was 2075, then plus 0.135897436 times 0.864102564. And that is all divided by our second sample size, which was 390. Okay, so all of this is going to be the left side of this confidence interval. And I'm not going to write the right side, but basically to do the right side, you would just change this minus to a plus, and that would give you the right side of this confidence interval. So let's see if we can calculate those two values on our calculator. We want the true population difference in the middle. That's why it's just P, not P bar or P hat. So let's type this in. 0.109398 minus 0.135897436 minus the square root. Oops, I left off our z statistic. We have a critical value that we need right here. And remember that we actually looked it up a little earlier. Our critical value was 1.51 with the absolute value. So even though it was negative, in this case, we always do the positive critical value. So we need a 1.51 right there multiplying with the square root. So sorry about that. So we have our two proportions subtracting each other, and then it's going to be minus the critical value of 1.51 times, and now I put in the square root and we put in all these numbers. And make sure that the second fraction is also in the square root. Okay. And when I do that, let's see how our answer compares. Yes, our answer is very close to the correct answer. It's not exact, so I should probably have used more decimal places. But the answer I get for this side is negative 0.05, which is really close to the correct answer. Maybe I just typed in a number incorrectly. The answer that the book got was 0.0504. I get negative 0.0546. So I don't know what's wrong with that. We're really close. If you're getting it wrong on the homework, you need to let me know if you're getting it just really close. Maybe there's something we're doing wrong. So our answer is really close to the right answer. Hopefully you would get it on your homework. In order to get the thing for the right side of the confidence interval, don't change this minus sign because it's still p1 hat minus p2 hat. The sign that changes is the plus. Oh, I know why we got it wrong. It's because I used the wrong critical value. This should not have been 1.51, my mistake. It should have been the value from the table, 1.645. So I'm sorry, I did that wrong again. 1.645 is the value we needed from our critical value table. So that I'm sorry about that. Remember, here's the table for the critical values for the confidence intervals. 1.645 is the value we needed. I put in our, and no, it's 1.282. I'm sorry. It's 1.282, critical value. It's different than a test statistic. Do you see how easy it is to get this confused? Like, I'm going to leave this in the video so that you understand that even though I've taught this class for maybe 5 semesters now, I still get things mixed up because this is hard and there's a lot of values. And so I need you to understand that it's okay to make a mistake. 1.282 is our critical value. And so hopefully, if you were confused by that, now you're not confused anymore. So let's actually clear this and go up to here and change it to 1.282 and see if that makes a difference. Yep, and notice we get the exact right answer now. So if we use the correct, critical value, which was 1.282, then we get the correct answer of negative 0.504. So I apologize for that. Just know that I understand if you miss these because there's so many ways to get them incorrect. Critical value was 1.282, which was from the table. 1.282 right there. Okay. Let's go ahead and replace the minus sign with a plus sign to get the right hand. Remember again, don't mess with this minus sign. We want to keep that minus sign. It's the second minus sign that needs to become a plus. And I hit enter, and we get negative 0.0026 if we round to where the book wants us to round, which is correct. So here, finally at last, is the confidence interval. So if the confidence interval contained 0, then that would have been similar to us failing to reject the null hypothesis, because it means that we can't rule out that there's no difference between the two groups. But because the entire confidence interval is below 0, So in other words, because it does not contain 0, there is a significant difference between the two proportions, and there is sufficient evidence to support the claim that commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. So everything that's written on the page right now is correct now that we have 1.282 right there. So remember, with these confidence intervals and proportions, what we care about is, does it contain the number 0? And if it doesn't contain the number 0, then that means we can reject the null hypothesis. I know this was a little rough to get through. If you have any questions, please email me. We're going to do another example and hopefully do better on the next example.